What I have down here is an NLT. It's a neon light transformer. It's 15,000 volts with just 30 milliamps, and it's AC. On top of it here, I've got my bridge rectifier. So I've rectified the 15,000 volts, 30 milliamps into DC. Over here on the red side is the positive coming out of the rectifier, the transformer, and on this side is the negative. And what I want to show you is hanging here on this little apparatus, on these insulated threads of fishing line, I have 3 steel balls. The outer 2 are solid ball bearings, and the center one's hollow. And it works with all 3 solid, but this does a special thing I want to show you. And these are my electrodes. They're copper. And what I want to show you first is that when you take an electric current and push it through the air or through a mass that's not thick enough or dense enough to conduct it, you get a Birkeland current. So the first thing I want to show you is the Birkeland current that this transformer, 15,000 volts, 30 milliamps, bridge rectified into DC, going this way, positive here, going to negative ground over here, what the Birkeland current or the arc looks like. So we'll do that. Let me get it just a little closer. That's what the arc looks like. Let me stop these from swinging and do it again. If you notice, they move a little bit when I electrify them. If I leave that on, it'll come up here and burn my fishing line, but you see how that does. You see the Birkeland current, the arc. Now next, I'm going to set it up where you can't see that arc, but the electricity still travels through these 3 ball bearings, spheres, and we'll do that. Okay, now what I want to show you is I have this set up at a particular distance on my electrodes from the ball bearings. This is my switch. I'm going to energize and let off and energize and let off, kind of pulse it, and it'll get the ball bearings moving. But the point of this is you don't see the current. It's what they call the Birkeland current dark mode. You can't see it, but you know it's there because of the displays it makes, even though you can't see the arc. So I'm going to pulse it until I get them moving, then I'm going to lock the current on, and you'll see how it continues that. Now I've locked it. The electricity's running steady now. I'm not pulsing it anymore. As you can see, nothing's causing that to happen except for the electric current. And it is from the weight of them coming back from moving, trying to go to center and hitting each other. But the point is the electric current keeps that going even though it's in dark mode. You do not see the current moving, but it's there. You can call it the electromagnetic field, or however you want to explain the dark mode of the electric current causing that to happen. It will continue to do that. Just like a clackety clacker. And I'm going to let this go just a second so you can see I'm not doing anything. There's no batteries involved. It's just the current from the transformer rectified, going from positive to ground, and the motion of the balls going from leaning out and the gravity pulling them back and them hitting each other. But it's a constant. It gets into a rhythm. And the rhythm's not really what I'm looking at. It's just, this shows you what it does. Now what I want to show you is when I shut the current off, it'll stop. And here we go. 1, 2, 3. Current's off. And it stops. And I'll possibly get it going again. Let's try it. You gotta pulse it to get them swinging. But there's no arc, if you notice. And there they go again. That was a chain on my door. The wind's blowing. That was that noise you heard. The lock on my door. But it'll do this, and if it gets far enough, it'll get the other one involved, and it'll go back to being like a clackety-clacker. But it'll continue to do this. There it goes. And like I said, I'm not doing anything to this, just letting the electric current and the natural pendulum gravity swing of the balls gets in time to do this. But the point of this is how earthquakes work. When the planets line up, that electricity, dark mode Birkeland current moves between them. And it just takes 10 seconds to 20 seconds, maybe a minute, depends. And that's when you feel the earthquakes on the earth, is when that electricity is moving through. And I will explain, if I haven't already, why that causes the earthquakes and the tectonic plates to do what they do. They don't do it on their own. It's the juice going between the planets, through the planets, that causes the earthquakes, especially here on Earth. So this is this part of it, the live demonstration of the dark mode Birkeland current. And let me show you again. If I shut it off, it quits. The earthquake is over. And what I need to explain here is when the earthquakes happen and the dark mode is between planets that causes earthquakes on the Earth, it's not moving the planets as this experiment shows. It's just that this shows that the current does move between the planets, but we can't see it. And it's, millions of volts, and who knows how many volts and amps it is that does that, but there's no air or anything out in space enough to cause the arc. So it's just moving between planets, and it causes the earthquakes. And like I said, I'll explain a lot of this more later. It does probably cause, as I've said before, the core of the sun, the core of the planets are magnets. They are huge nickel iron magnets, and they're magnetized. That's why they interact. That's why they spin like they do. That's why they orbit like they do. But I will show in the next part of this how the cores of the planets may get pulled inside the planet with the current, whichever way it's going. And I'll explain a lot of the direction of the currents later, and I'll explain a little more about the cores in this video. But it's the cores that might move, but it's the Birkeland currents that cause the vibration, everything that happens with an earthquake, and even volcanic activity and atmospheric storms. A lot of this is connected directly to the planets. So we'll move on and show you more about how the cores possibly have a lot of interaction with how, especially on the Earth, how the earthquakes display what they do. And we'll do that. Okay, now if you notice, I've got a real small metal bearing in between the two larger ones. So if you will, the center planet, this is the core, the iron nickel magnetized core. These two are regular planets, but this is just a core, like the core of the Earth, let's say, when three planets line up for an earthquake. And I don't have a capacitor hooked up to this, which would make it probably go one way and stay there when I energize it, but I'm not spending $200 for a capacitor that may not even do what I'm hoping would happen. But what I'm going to show you now is when I take the control here and I energize it, I'll get them moving a little bit, but I want you to see what the center bearing does. And remember, it's like the core of the Earth. And the cores of these planets are not smooth like ball bearings. They're lumpy. They're not perfectly round spheres. They're spheres, but they're lumpy. They have ridges and mountains and valleys on them, pretty good size. So, and these are all, the cores are rotating inside the planets. So there's a different speed of rotation. And even if it's the same speed, the current moving this is going to try and slow it down or possibly speed it up. But here we go. I'm going to show you what happens when an earthquake happens to the core of the planets. You notice it loads up and unloads with the current from the positive to the negative. It loads up and unloads, loads up and unloads. You can see how it just radically moves back and forth. and it'll go from one side to the other, but it goes back and forth, but it'll come towards us and away from us as it does so to centralize. But that's what the cores of the planets, they're moving side to side as the lineup for the current happens. I'm just leaving the current on. If I shut it off, it quits. If I kick it on, it goes back. You know, it just happens. But as that's spinning and it rubs the side of the inside of the planet that's around it, you know, the outer elements, you're going to get a lot of vibration at the place where it rubs. I think that has a lot to do with the intense vibration the Earth feels during an earthquake. So that's part of this too. Part of the anatomy of an earthquake is the core is rubbing the inside of the planet on the side, one side or the other, the positive side or possibly the negative side, depending on the current. Now, as you can see, I have a ball or a BB in there, a very small one. This is the one I used previously, a little bigger. But in there now I have a bearing. It's like a BB for a BB gun. That's the size of this little ball bearing in here. And it basically does the same thing the larger one did, but it's a little more intense. Let me stop these from moving. And we'll do the same thing we did a while ago. I don't know if you can see it on the camera, but it's comes towards us, goes away to the back side, front side, as it goes back and forth. I ain't leave it on, it does that. Kick it off and it stops. On, off. On, off. That just shows you more of what I say, or Porpoise proposes, is how an earthquake, the anatomy of an earthquake, especially here on Earth. Okay, on this demonstration, I've got 5 little ball bearings in a line. 1, 2, 3, 4, 5. And they're real close to each other, as you can see by the camera. I can kind of lean them into you, if you see how close they are. And they're in line, okay? Which is no big deal. Let me get this set up again. But what I want to show is how the arc will go between them. You see that? It arcs between all 5. And what I want to show is, you know, when the planets line up, that's what's happening. But it doesn't have to be in a perfect lineup, is what I want to show next, as I do this. And let me see if it's going to work like it normally does. Even with one out of line, I guess you can see that. One's quite a bit out of line. This one here is quite a bit out of line. But even though it's not perfectly lined up, you still get connection. And I know this is, you know, it's obvious that there's only so much room between them, but that's the point of Porpoise, is that when the planets line up, they don't have to be perfectly in line. You see that? One of them can be out a little bit. You know, and I can remove the outside 2 and show you just 3 planets. Let me set this up a little tighter. So that even though they're just out of line somewhat, you can still get an interaction. So that's the point of this. They don't have to be perfectly in line. They can be out of line a little bit. That's the point of this.